DIY IBC Tote hot tub / cold plunge. I took an IBC tote, I cut the top off, I insulated it, filled it up with water, and then I put a coil inside that I built out of copper. Then I connected that to a heat pump outside. I'm going to show you how it works, how I built it, and how much it cost to run. And this is pretty much a high efficiency heat pump hot water heater. You're watching Taddy Digest. I'm Tad. Let's get started. This DIY project required 4 components. This is the first component. This is a heat pump outdoor unit. And if you want to make the water cold and hot, then you need a heat pump. This is a Samsung Hilux universal outdoor unit. If you want to learn more about the Samsung Hilux unit, click the link to this video or check out the link to that video in the description where I installed this in a project that I had. So this is my heat pump outdoor unit. This is my panel where I wired it up. And you can see I've got a disconnect to power the unit. I've got my power that comes in. I've got my communication wire that goes to my control. And then I've got my liquid and my gas pipe. And these line sets enter the building. Now I'm going to show you the other 3 components. Component number 2, IBC Tote. You can see the top is gone, and I'm going to show you in today's video me cutting the top off and insulating it, but this is called an intermediate bulk container. It's used for storing liquids and powders, and you can find these from free like I did because I had a friend who had it and he gave it to me, but sometimes you can get these as low as $25, $50. Sometimes they're a lot more expensive. And this one actually stored alcohol. So alcohol 1214 with BHT. So I did clean this one before actually cutting the top off and foaming it. But this is my second component. Component number 3, heat exchanger. This is a heat exchanger made out of copper. And this is what I'm going to use as my evaporator and my condenser. My evaporator during cooling and my condenser during heating. So you can see the line sets from the outdoor unit come into the building, and then they go into this coil that I made, which I'm going to show you how to make this coil, and then it's submersed in the water inside the IBC tote. This is component number 3. Component number 4 is the controls. The controls are right here. Now disregard this. This is a Renko electronic temperature control. I'll explain that later on in today's video. We'll probably use this at some point, but right now I've got a thermostat, a transformer to power this control, and then a contactor because I will hear a click whenever I use heat or cool, and I will know for sure that we are engaging that mode of operation. So this is the AHU control. This is made by Samsung, and this is a control they use to be able to communicate with that outdoor unit and use that outdoor unit to make it compatible with a gas furnace, with a heat pump air handler, with a fan coil unit. So here's my communication wire. It comes into these terminals, F1 and F2. Then I've got a thermostat wire, so my thermostat can communicate to this board. And then I've got RNC, and my transformer is used to power this RNC to give the board 24 volts. And then on my indoor unit, I've just got a wire for Y, and it's tied into the coil of that contactor. So it will energize that contactor and close a set of contacts. But the contactor really does nothing. So what does something is the thermostat communicating to the AHU, and that's what turns the outdoor unit on. Wanted to explain that, but those are the 4 components. Now I'm going to show you how it works. First, we turn on the power. There's the breaker for the outdoor unit and the breaker for the transformer. We got lights on the AHU control. 640. I'm going to turn the thermostat to heat first. We're going to check the water temperature before we begin. It's exactly 80 degrees inside the water. It is pretty warm outside. It's pretty warm in here. So we'll leave that in there. It's 80 right now. And 640. When the unit comes on, it'll probably be about 6:45 because it's got a little bit, well, actually, it may come on sooner than that. And then I'm going to come back in a few hours and check it. We'll see how fast the water temperature rises. I hear it. It's running. All right, I'll be back. I'm back. It is 10:03, so it's been, we started at 6:40. It's 10, that's 3.5 hours. I'm going to drop the sensor in. Turn on the meter. Oh, it's 98. Wow, so 100 degrees right now. So, wow, it does get hot. That's awesome. Put this over here. Feel the water. Oh, it's warm. It feels good. All right, let's hook up the clamp and check the temperature of that vapor line. All right, we've got this little temperature clamp hooked up to the meter. It's on Fahrenheit. It's 111 degrees. So this copper line is warm. Really warm. Okay. So that's the test for heating. I'm going to turn it off now. And I'm going to let this water, the temperature of this water, go down a little bit before we turn it on cooling. Back on site, and now I'm ready for the cooling mode. So let's check the time and let's check the temperature of the water. So here's the time. It's 4:50. Let's just call it 5 o'clock. It's 4:58. And the temperature of the water is 91 degrees. Let's call that 90 degrees. Let's go ahead and turn it to the cooling mode. All right. It's 85 degrees in here. Ooh, it is warm. Let's put it on 60. Should hear a click. Well, once this thermostat calls, oh, click, and then we're in cooling mode. Outdoor unit is running. Back on site, let's check the temperature and the time. Time is 8:13, so it's been about 3 hours. Let's drop the sensor in the water and check the temperature of the water. Wow, 61 degrees. That's excellent. So from almost 100 down to 60, 40 degree drop. Let's check the temperature of the suction pipe or the gas pipe. 55 degrees. That's excellent. Now I'm going to show you how to build this. To make the coil, it's very simple. I'm taking some leftover 3/8 copper and some 3-inch PVC. I've got it in the vise so I can hold the copper and the PVC together. And then I'm just taking and rolling the copper over the PVC. And if you don't get the copper against that PVC, it's going to bend and kink the copper. And try to keep it as close together as possible, but I want a little bit of a gap. Reaching the end, like that. See? And there it is. And then, before you take it off, if you want it closer together, push it. You may want to do that anyways. Yeah, it's really crooked, but it doesn't have to be pretty. Now, once you get it where you like it, loosen up the vise, and then slide that coil off. Look at that. See? Now I've got my 2 coils. Now that we've bent the copper into the shape that we're going to use for the coil, I'm going to show you the fittings and the tools I'm going to be using to make the whole assembly. We've got a set of oxyacetylene torches. I just finished taking my tubing cutters and cutting all the ends off of the little rolled up 3/8 copper coils that we've made. And I'm going to evenly space these out. And once I get them evenly spaced out to where I think I need them to stay, then I'm going to take a couple pieces of 3/8 copper, maybe one here at the bottom and one here at the top, and I'm going to braze those in so that this stays where it needs to stay. Then we're going to start installing some fittings. I've got 5/8 T's, 3/8 T's, 1/4 inch T's,
And we're going to have an inlet and an outlet. And our inlet is probably going to be at the top and our outlet's probably going to be at the bottom, or vice versa. I'm not sure yet, but I know that we're probably going to have 1/4 inch copper coming in, and we're going to have 5/8 copper going out. I'm going to start the brazing process, and let's go ahead and turn this into a coil. Now I've got the 3/8 tubes somewhat welded together, and now I can pick it up and it's one assembly. Now that I've got this done, I'm going to start welding these T's and elbows together, and I'm going to route these 3/8 tubes into those 5/8 tubes. And then I'll start on the other side. Look at this crazy contraption so far. So that right there is one side, and that is the outlet. Now we're going to make the inlet, and this is going to be 3/8 going to 1/4 inch. So, all right, let me start brazing and get that done. Well, there's my coil. What an absolute monstrosity. I could have bought a coil. I could have got a Geo coaxial and used that. Make sure you don't have any leaks. Make sure you pressure test the coil if you're going to build one. Make sure you know how to braze. If you don't know how to braze, I'll put a video down below so you can learn how. Here it is. 1/4 inch coming in, 5/8 going out. You want to get an IBC tote that hasn't had some type of hazardous chemical, something that's easy to clean out. This one just had alcohol in it, so I found it, and now I'm going to cut the top off using my little Milwaukee hacksaw. I've also got a metal blade. I'm going to show you right here. We're probably going to cut it off right here below this first ring, and I'm going to cut through all of these as well as the plastic. So I'm going to cut this whole top off, and you can use a Sawzall or a hacksaw. So get a Sawzall or a hacksaw, and I'm not going to make you watch me cut all these, but you can see what I'm doing here to get the top cut off. See how I'm cutting all of these metal pipes, and I'm not worrying about the plastic yet. We're going to switch blades, then we'll cut the plastic, but you can see I've cut through almost all of these. Had to get a new metal blade. Make sure you have a couple extra blades just in case you need them, but the hacksaw is doing really well. So now that I've got most of the metal pieces cut, now I've got these two pieces on top. See these plastic pieces here? And one here. Now I can take the metal cage off the top. Trying out the circular saw. Circular saw was a success. So, next step, clean it out. After we clean it out, we'll need to sand all these edges. Maybe even cover this with some type of foam. That way when you get in and out, you don't cut yourself. But definitely make the edges to where they're not sharp. I filled it up with water, let water set in it last night. So I'm going to get all the water out, and then we're going to take the plastic part, and I'm going to pull this out of the metal cage. All right, got all the water out of the IBC tote and didn't really scrub it. I may need to do that at some point, but this is all experimental, so I need to make sure it works first. But I should be able to take this out of here now. But the best way to do that would probably be flip it on its side. Oh yeah. Oh, this lever. I gotta put it back in. There it is. Now, I'm gonna bring it over here and flip it upside down, so that's gonna be the best way to insulate it. I ordered some spray foam from Sprayman. This is their thermal and sound insulation. It's quite a large can, and it comes with these red tips on the end. I'm going to be using tip A. Tip A is going to be for vertical application. Tip B is for ceiling application. There's what we're going to be spraying, and I'm going to spray a very thin coat because I don't want to spray it so thick that we're not able to actually get the plastic back into that cage. And I know if I get it too thick that it's going to be impossible. Here's the little spray gun, and then here's the foam cleaner I'm going to be using to clean the gun out. That way I can reuse this. But I ordered 6 of these cans, so I'm going to shake them up and get ready. All right, now to attach the spray foam, I'm going to take the top off, and then I'm going to attach my tip. Attaching the can. Third side. I'm going to get that last side, we're going to let it cure, and then we'll slide it back down. When you are finished using the spray foam, you need to be able to save the spray gun. So you use the foam cleaner. Once you attach the foam cleaner, pull the trigger, you'll see the foam come out, and then we can remove this tip and we can reuse the spray gun. I love the fact that you don't have to buy a new spray gun. Spray gun's around 20 bucks. I just insulated my shed using Sprayman spray foam. If you want to check out that video, I'll put the link right here, or put the link down in the description for you as well. So there it is. Now it's cleaned out. We can reuse it. And I only used a little over a can to insulate the IBC Tote, so I'm excited. We're gonna let it dry, let it cure. It's probably gonna take a couple hours, and make sure you use this when it's the right temperature. It has to be above 41 degrees. It's a little chilly this morning, but it's over 41. So make sure you read the instructions. Can's gonna give you suitable storing temperature and suitable application temperature. Sprayed the IBC Tote, and it's been a few hours. It feels like it's hardened up. I know that you should probably wait at least 8 hours, maybe 24 hours for it to fully cure. I don't want to wait. So I'm going to, I guess, pick it up. All right, bring it over to where the cage is and try to set it in the cage. I hope this is a good idea. I've got some of this bubble wrap type insulation. I'm going to cut some small strips, and that's how I'm going to keep from, one, getting hurt, you know, when climbing into the tank if this works, and then two, keeping the foam insulation being cut off or scraped off when I put the plastic piece back inside the cage. I'm going to take some polykin duct tape, and I'm going to just take and tape this. Now that I've got the little protective coverings for those sharp areas, now we're going to pick up the tank. What are you doing?
I don't know.
Get on the other side and pick up the tank, please.
Yeah. Oh, I thought it was going to be heavy.
It's a piece of plastic.
I don't. I was getting ready to squat.
That is not going to fit. No. So it doesn't fit. I'm going to cut right here all the way down. That way I can spread it apart, put it together. All right, so I'm going to cut here, here, here. Let's do it. So only idea I could come up with, put my daughter inside. All right, go ahead and jump. All right. So we got it in. Let's bring it inside. Front, and then our coil will be right here. I need to move these out of the way. So got my coil sitting inside the IBC Tote. We are ready to tie in the coil, so I'm sanding off those connections, and I am going to connect this 5/8 90 from my line sets to my coil connection. I've got the heat pump outside already wired in, and I'm gonna braze this connection, and then I'm gonna leave this one, and I'm gonna blow through this line and then back out here just to clean anything out that could be in there that could be harmful. I'm very excited because we're getting close. Once I braze this in, we'll nitrogen pressure test it. It's critical that I don't have any leaks, because if I do have leaks, we could have water get inside those lines and go back and basically ruin the unit. I don't need that. Copper will last a long time, and that's why we have copper water lines, and there are main water lines that are underneath the ground that last 50 years. So this should last at least 5 years, 10 years. I won't need it more than a few years, I'm sure. This is all experimental, but we're getting close. So I'm going to go ahead and braze this connection. I'll show you the condenser, and we'll fill it full of nitrogen and blow this out. And then I'm going to use the RLS tool to make the last connection. I did not use nitrogen while I'm brazing because this is just an experiment and something fun to do, but you should always braze using nitrogen. Now, before we braze this connection, which we're not going to braze it, we're going to use the RLS. Now we're going to pump nitrogen through this line and blow everything out. Samsung Hilux condenser, nitrogen. Oh, wrong. Now let's go through the other one too. Alright, that should do it. Now tying in the 1/4 inch line, and I've already marked it with my little depth gauge. Alright. If you don't know anything about the RLS tool or how to use it, I'll put a video down below so you can learn how. Alright, we should have a sealed system. Alright, valves are closed on the unit. We'll open those up after we do a vacuum. We got 300. We're going to let it set on 300 for at least 30 minutes. And I'm going to go soap test all of my fittings. Filling the IBC Tote up with water, and that is going to be another good way for us to leak test, because once we get water over all of our connections, if we see any bubbles, then we know we've got a leak. But so far, no leaks. Almost filled up all the way. Now that I got the water level where I want it, I'm going to wait and watch for bubbles. And I'll show you the nitrogen pressure test, or pressure that I've got on it. Still got 300, well, right below 300, that mark right there, it's 295. Now to move forward and pull a vacuum. So I'm going to take and let the nitrogen out. Started up the vacuum pump. We're going to pull a good vacuum, and I'm going to hope that there are no leaks. It's been probably 5 minutes, and it's already at below 250 microns, so I'm about to stop the pump, and I'm going to open up the valves using the Allen tools. Opening the valves. Both valves are opened. Breaker for my unit, on. Breaker for my transformer, powers my thermostat, on. 0, 0, 0, 0. Nice. All right, we should be ready to run. Got some standing pressure on there. All right. So right now, I don't have a way to control the water temperature, and I want to talk about controlling the water temperature with something like this. This is a Ranco electronic temperature control. This can be used to control the water temperature because there is a sensor right here, right? And there's a set of contacts that open and close. You can put this inside the water, and then there's another control you can use. I'm going to talk about that. You can use an aquastat, and an aquastat is used in hydronic systems,
and that is used to control the water temperature. So you could use an aquastat as your control, and you can make this more efficient. Right now, I've just put together controls for testing and experimenting. This was all an experiment, and I wanted to do this because I just love tinkering and I love projects like this. So let me know if you like just building different things and just testing things out. Now, to figure out how much this costs to heat our water, we need to take a few measurements with the meter. Let's do that.
So measuring the temperature of the gas pipe, it's 108 degrees, so around 110 degrees. We're going to take our meter now and connect our leads. Now we're going to use our meter. We're going to turn it to volts AC. We're going to use our meter leads, and here's our 30 amp double pole breaker that powers that mini split. So we're going to measure 240 volts. So we need volts, and then we need amps, because that's how we figure out watts, and that's how we figure out how much it costs. So now we're going to take our meter and our clamp, and we're going to clamp it around one of our lines, and it's 5 amps, 5.3. So now we have our amps. See that? Amps. So 5 amps and 240 volts. So that we just times those together, and then we can figure out our watts. And I'll show you that in the video so we can figure out the calculation for kilowatt hour, and then how much it actually costs for a whole day of heating water. Now we're going to dive into the calculations and figuring out exactly how much it costs to operate this heat pump water heater. Then we're going to compare what it costs to run this heat pump hot water heater and what it costs to run a regular tanked electric hot water heater, which on average they run around 3 to 5 hours per day. So we're going to use the 5 hours, and then it costs in between 4,000 to 5,000 watts to run an electric water heater. So we're going to use about 4,500 watts. If you want to learn more about these calculations and how I do this, I just did a video titled "How much does it cost to power an air conditioner?" I'm going to put that video link right here, and then I'm going to put the link to that video down below. Now, if we had a really good tank that was insulated really well with a pre-made coil inside and then quick connections on the outside, then this would be a great product. You could actually just sell a mini split heat pump. You could sell the line sets, the control, the wire, and then that tank, and then it could be connected together very easily. And then that tank would hold and retain the heat that mini split heat pump produced. So let's go into the calculations and figure out how much savings we would have from using this compared to the traditional hot water heater that's electric. Here we go. So heat pump hot water heater first. 240 volts times 5 amps, that's what we had, equals 1,200 watts. Divide that by 1,000 to get kilowatts. 1.2 kilowatts, times that by 5 hours of runtime, that is 6 kilowatt hours. Times that by what the electric company charges, let's say 8 cents, equals 0.48, so 50 cents, and then times that by 30 days. So $14 per month to run that heat pump hot water heater. So $14, right? Keep that in mind. Now let's use that 4,500 watts as an average for that 50-gallon hot water heater that's electric. And then we're going to take and divide that by 1,000, which equals 4.5. Then we're going to take that figure times 5 hours, 22.5 kilowatt hours, and then times that by 0.08. That would equal $1.80. Times that by 30 days. For a month, it would cost us $54 to operate that electric hot water heater. Minus 14, and then we have a savings of $40. You times that by a year, wow. That is $480 you saved. That's awesome. So we were able to figure out what our cost and our savings would be by doing a few different measurements with our meter and then using our calculator. I love experimenting. I love fun projects like this. And now I'm able to see that this could be the future of heating water. Then you take this, then you couple it with solar power. Wow. You just saved a lot of money and it became more efficient. How hot will the water get? I'm not sure. I only used this heat pump in the heat mode for around 3 hours. Same thing for the cool mode. If you want to see that,
Comment below, let me know. I'll leave this thing on for a whole day. I'll leave it on for 8 hours in heat or cool, and we can see just how cold it gets. This was just an experiment, and so far this is the data that I have gathered from the experiment. Had a lot of fun with this project. It's cool to see a high efficiency heat pump used for this application, heating water. What if this mini split was solar powered? I think that would make it even more fun. I think that would make it even cooler. Let me know if you enjoyed seeing this. Let me know if this gave you ideas. Let me know if you liked the video. Let me know if you learned something. If you learned something, let me know in the comments what you learned. If you liked the video, hit the like button, subscribe, and smash that bell. Ding! So you know what I'm doing. You've been watching Taddy Digest. I'm Tad, and I'll keep you cool if you let me.